Today, we're going to pull back the curtain on one of the coolest and honestly most underappreciated magic tricks happening inside your computer every single second: true multitasking. This is all about the unseen force that lets your machine do, well, everything at once. I mean, think about it. Have you ever wondered how your computer can be downloading a massive game file, you're streaming a 4K movie, maybe you're on a video call, all at the same time and it just works? It doesn't crash, it doesn't even stutter. How is that possible? Now, you might think the answer is just a really fast processor, but that's only part of the story. The real secret, the hero of this whole operation, is a specialized and incredibly efficient assistant working behind the scenes. Its entire job is to handle all the grunt work, so the brain of the operation can focus on what's really important. Okay, so to really get why this assistant is such a game changer, we first have to meet the boss, the CPU. And you'll see that in the early days of computing, this boss was, well, a bit of a micromanager. Just imagine your computer's CPU is like a brilliant CEO of a huge company. Now picture that CEO not just making the big company-defining decisions, but also personally running down to the mailroom for every single package, carrying every piece of data to the right desk, and then just standing there waiting for a reply. It sounds absurd, right? But that's pretty much what computing used to be like. And this micromanagement style, as you can probably guess, created two huge problems. First, the entire company's speed was limited to how fast the CEO could literally run back and forth. And second, while the CEO was playing mail carrier, no actual brain work, no important thinking was getting done. The whole operation would just grind to a halt for these really simple, tedious tasks. So the engineers back then came up with a genius solution. They asked, what if the CEO didn't have to do all that? What if the CEO could delegate all that mailroom duty by hiring a super capable assistant? And that is exactly what direct memory access, or DMA, is. The idea is actually pretty simple but incredibly powerful. Let's create a special pathway for data to move directly between your hardware, things like your hard drive or your network card, and your computer's main memory, completely bypassing the CPU altogether. And the assistant that makes all of this happen is called the DMA controller. It is a dedicated piece of hardware. Its whole purpose in life is to do one thing and do it extremely well: move big chunks of data from point A to point B, leaving the CPU free to do much more important things. So, how does this whole delegation process actually play out? Well, it's a really simple 3-step workflow that turns our overworked CEO into a master of delegation. Check out how clean this process is. The CPU, or CPU, just hands over a simple to-do list. It says, hey, please move this much data from this location over to that location. Just let me know when you're done. And that's it. The CPU is now completely free to work on other things. The DMA controller handles the entire transfer, and only when the whole job is finished does it send a single, quick message back to the CPU saying, I'm done. Now, you might be thinking, okay, but to move all this data, the assistant still has to use the office hallways, right? And you're absolutely right. To get its job done, the DMA controller needs to use the system's main communication pathways, which are called a bus. It does this by cleverly borrowing the bus for a split second right when the CPU isn't using it. This is called cycle stealing, and it's a key part of what makes this whole process so seamless. The very first designs, well, they were a little clunky. The DMA controller was a totally separate unit. So for every single piece of data, it had to use the system bus twice. Once to grab the data from the device, and then a second time to write it into memory. This meant the CPU had to be paused twice for just one transfer. Not super efficient. So, of course, the next step was a much smarter setup. They integrated the DMA assistant directly into the I/O devices themselves. Now data could go straight from, say, the hard drive to the memory in one single hop, using the bus only once. This means the CPU gets paused just once, which, as you can imagine, makes the whole system a lot faster. The next evolution was even better. It was like giving the assistants their own dedicated highway. By creating a separate I/O bus, large data transfers could happen completely on their own, without ever needing to use the main system bus that the CPU relies on. It's like building a separate courier route, so the mail never, ever clogs up the executive hallways. This whole DMA concept was so incredibly successful that computer architects basically decided to double down on the idea. They figured, hey, if one great assistant is good, what about giving the CEO an entire department of assistants? And this thinking led to the creation of even more sophisticated hardware, like I/O processors and channels. You see, these weren't just assistants anymore. They were more like highly autonomous department heads that could manage incredibly complex data operations all on their own. So take an I/O processor, or IOP. This thing is basically a mini CPU in its own right. The main CPU, our CEO, can just tell it, hey, go execute this entire program for managing the network. And the IOP handles everything. It fetches the instructions, it manages the data flows, all without any more input from the CPU until that entire complex job is complete. And these new department heads generally came in two main flavors. You had a selector channel, which is kind of like a specialist who focuses on one high-speed device at a time. Think a super fast storage drive. And then you had a multiplexer channel, which is the ultimate multitasker, juggling data from lots of different, often slower devices at once, like your keyboard, your mouse, and your printer. And you can really see the difference in their design philosophy right here. On the left, the selector channel provides this dedicated, high-speed path for one task. But on the right, the multiplexer is built to weave together data from multiple sources, which makes it absolutely perfect for managing a bunch of slower peripherals all at the same time. But here's the crucial point, the main takeaway from all of this. From that first simple DMA controller to these complex I/O processors, the entire history of this tech is all about one simple principle: delegation. It's about letting the brilliant CEO, the CPU, focus on the complex thinking it was designed for, while an army of capable assistants handles the busy work of just moving data around. This whole system of delegation is the real reason your computer feels so fast and so responsive today. But as we dive headfirst into an age of AI, virtual reality, and just massive, massive data sets, the amount of data we need to shuffle around is skyrocketing. So that leaves us with a really fascinating question. What will the next generation of these unseen assistants look like? And how are they going to be designed to handle the absolute data deluge of tomorrow?